Hello, my name is Matthew Gambale. I work with Professor Julie Shaw in the Interactive Robotics Group at MIT. Advances in robotic technology are opening up the possibility of integrating robotic teammates into new areas of the factory where most of the work is currently done by people. However, integrating these robots may make human workers feel devalued and create resistance to the technology. For this new technology to be a success, we need to understand how to gain the support of the human workers who will utilize this robotic technology. We hypothesized that a human-robot team would be more efficient when the robot had more control over scheduling decisions. However, giving complete control to the robot would make the human worker feel devalued, and giving complete control to the human would be too burdensome. Thus, we expected to find a sweet spot to maximize efficiency and worker satisfaction when the control was shared. To test our hypothesis, we invited 24 people to participate on a manufacturing team with a human assistant and a robotic assistant. There were two types of tasks, fetching parts bins and assembling parts bins. There were 2 locations to fetch parts bins and 2 locations to assemble parts bins. No 2 workers could be working at the same location at the same time to adhere to safety standards. Fetching a parts bin consisted of verifying the correct Lego parts were in the bin. Assembly tasks consisted of putting together the pieces in a parts bin. The human teammates could fetch and assemble parts bins, while the robotic teammate could only fetch parts bins. There were 3 experimental conditions varying the level of control over scheduling decisions: manual, autonomous, and semi-autonomous. We confirmed that time to generate a schedule and time to execute that schedule was better when the robot had more control. In terms of the quality of the human-robot relationship and the robot's benefit to the team, we found that the human subjects preferred working with the robot that had more control over scheduling decisions. For example, subjects felt that the autonomous robot better understood them, the autonomous robot increased the productivity of the team, and the subject would prefer working with the robot that had more control. We also analyzed how people decide which team member performs which task. When subjects had control only over the work they would perform, subjects more frequently chose to pick tasks that did not rely on the performance of their teammates. Rather than finding a sweet spot where the human and robot shared the decision-making authority, we found that both team performance and the satisfaction of the human workers is most when the robot is fully autonomous. Our findings support the case for integrating autonomous robots into the human workspace. This work was sponsored in part by the National Science Foundation under the Graduate Research Fellowship Program. For more information on our ongoing work in the Interactive Robotics Group, please check out our website at interactive.mit.edu.